Have you ever looked up at the stars and wondered if we're really alone in the universe? It's a question that has captivated the minds of scientists and everyday people alike for centuries. With the vastness of space and the sheer number of stars and planets out there, it seems almost impossible that we could be the only intelligent life form in existence. But what if aliens do exist? And what if they've already made their presence known in ways we never imagined? What would happen if an alien spacecraft clashes with one of our satellites? Would we know? Well, what we're about to uncover may indicate such theories. Hello and welcome back to Mindful Moments, where we discover and explore the captivating realm of science, technology, conspiracies, and the universe. If you want to watch more videos like these, click on that red subscribe button and ring the bell to get notifications on our latest upload. NASA's Jet Propulsion Laboratory is currently investigating an unusual malfunction experienced by Voyager 1. The interstellar spacecraft is gathering data, but the readouts from its Attitude, Articulation, and Control System, or AACS, don't match what is actually happening on board. Even though the AACS seems to be operating normally, the data being sent back to Earth is invalid, generating random data that does not respond to any conceivable state of the system. The AACS is responsible for controlling Voyager 1's positioning and keeping its antenna pointed towards Earth to ensure efficient data transmission. If the spacecraft's fall protection systems are activated, it will be placed in a safe mode with limited functionality. The signal from Voyager 1 remains strong, but NASA JPL has noticed that the data it sends back seems to be distorted. NASA considers these types of anomalies to be typical for a spacecraft of its age, especially one that has been in interstellar space for an extended period of time. Susan Dodd, the project manager for Voyager 1 and 2 at NASA's Jet Propulsion Laboratory, acknowledged the difficulties that the engineering team faces in finding a solution to the issue, but expressed confidence that they will find a way to fix it. She added that if the source of the problem cannot be identified, the team will adapt to the glitch or fix it with a software update or redundant hardware systems on board the spacecraft. Voyager 1 was launched from Cape Canaveral after the Voyager 2 took off, but because of its faster route, it overtook its twin to fly by Jupiter in 1979 and then Saturn in 1980, according to NASA. It's also gone further than Voyager 2, which is currently traveling about 12.1 billion miles from Earth. Both Voyagers carry a message on a gold-plated copper disc in case extraterrestrials find the spacecraft one day. It also includes a player and instructions describing how to play the content. The disc includes greetings in 55 languages and 90 minutes of mostly Western music. The Voyager 1 spacecraft is a sophisticated piece of technology that was launched into space on September 5, 1977, as a part of a mission to explore the outer planets of our solar system. It was designed and built by NASA's Jet Propulsion Laboratory, or JPL, in Pasadena, California. It is equipped with a variety of instruments that allow it to study and gather data about the planets it encounters. These instruments include a magnetometer, a plasma wave instrument, a cosmic ray detector, and several cameras. The spacecraft is powered by 3 radioisotope thermoelectric generators, or RTGs, which convert heat from the decay of radioactive isotopes into electricity to power the spacecraft's instruments and systems. The magnetometer is used to study the magnetic fields of the planets and their moons. This information helps scientists understand the internal structure and dynamics of these bodies. The plasma wave instrument studies the electrical and magnetic fields of the plasma that surrounds the planets, while the cosmic ray detector measures the energy and composition of charged particles that are produced by the sun and other sources. The cameras on Voyager 1 are used to capture images of the planets and their moons, as well as other objects in the outer solar system. The spacecraft is equipped with both wide-angle and narrow-angle cameras, which allow scientists to capture images of varying levels of detail. These images have provided valuable insights into the geology, atmosphere, and composition of the planets and moons in the outer solar system. One of the most important components of the Voyager 1 spacecraft is its data storage system. This system is capable of storing vast amounts of data that is transmitted back to Earth for analysis. The spacecraft uses a low-gain antenna to transmit data back to Earth, which limits the amount of data that can be transmitted at one time. However, the high-gain antenna is also used when the spacecraft needs to transmit large amounts of data quickly. Overall, the Voyager 1 spacecraft is an impressive feat of engineering and technology that has enabled us to learn a great deal about the outer planets of our solar system. Its instruments and systems continue to operate more than 40 years after its launch, and its data continues to provide valuable insights into the mysteries of the outer solar system. The Voyager 1 was the first human-made object to reach into interstellar space, and in 1998 overtook NASA's Pioneer 10 to become the most distant human-made object. It reached interstellar space in August 2012 and, among other things, takes measurements of the density of material in interstellar space. It will eventually exit the solar system, but not for a long time. If we define our solar system as the Sun and everything that primarily orbits the Sun, Voyager 1 will remain within the confines of the solar system until it emerges from the Oort cloud in another 14,000 to 28,000 years, NASA notes. After sending garbled data for months, Voyager 1 has resumed transmitting clear telemetry data on its condition beyond our solar system. NASA discovered that the problem was with the spacecraft's Attitude Articulation and Control System, or AACS, which was sending the telemetry data through a computer that stopped working years ago, causing the data to be corrupted. Once engineers identified the problem, they sent a command to the probe to use the correct computer for communication. The AACS started sending the telemetry data through an onboard computer known to have stopped working years ago, and the computer corrupted the information, NASA officials wrote in an update. Voyager project manager Susan Dodd said in a statement, "We're happy to have the telemetry back. We'll do a full memory readout of the AACS and look at everything it's been doing. That will help us try to diagnose the problem that caused the telemetry issue in the first place. The reason for the malfunction remains a mystery, and engineers plan to do a full memory readout of the AACS to investigate the issue." Despite the incident, the mission managers believe that the problem is not a threat to the Voyager 1's long-term health. Voyager 1 seems to be functioning properly and is still able to collect and transmit scientific data. It can receive and carry out commands from Earth, but due to its vast distance, it takes about 2 days to receive a response. Despite the odd telemetry data readings, we can confirm that the spacecraft's antenna is still directed towards us, as we are still in communication with it. That is all for this video. We hope you enjoyed the video. Go check out on other videos about the unique James Webb Telescope and its discoveries. And if you like this video, give us a thumbs up and don't forget to hit that red subscribe button to encourage us in making more videos like these in the future. And if you have any mystery, scientific discoveries, or conspiracies you want to share, let us know in the comments below. We're Mindful Moments, dedicated to exploring the captivating realm of science, technology, conspiracies, and the universe. See you again in the next video.